Hello, my name is Nathaniel Worlich. I'm a bio major here at Truman State University, and I'm going to be presenting on the topic of the Lone Star Ticks transmission of vector-borne HME. All right, Lone Star ticks have been studied to be directly responsible for the transmission of HME to humans. The adult transmission rate of adults Lone Star ticks transmission rate of ehrlichiosis to humans is between 0.9% and 19%, and nymphs are found to be 0 to 5%. The Lone Star ticks, how they do this, they carry the pathogen from the white-tailed deer onto humans. So ticks transmit the pathogen through biting the host. Ticks are linked to being active in the same season that ehrlichiosis reported, and this map demonstrates that well by the red being the reported cases of ehrlichiosis. So the red right here being the reported cases of ehrlichiosis with the presence of the Lone Star tick, and then we have the green, which is reported cases of ehrlichiosis without the presence of the Lone Star tick. Now the green, it doesn't have the Lone Star tick presence in it, is believed to be from, because this is where there are reported cases, so it's believed to come from areas of where there is a Lone Star tick, and then them only noticing their symptoms and going to the hospital once they get back to these areas after travel. But there's also been areas where there isn't reported cases of ehrlichiosis. Then there is the presence of Lone Star tick, and that would be the orange areas that we see right here. So ticks are linked to being active in the same season of ehrlichiosis. However, nymphs tend to match that season a lot closer than adults do. Now, the tick season is regulated highly by temperature and humidity, since they're temperature and humidity dependent creatures, which we will discuss a little bit later in the slide. Now, HME, it causes flu-like symptoms in humans, and it is transmitted by the Lone Star tick, and it is predominantly, as seen in the last slide, in the southeastern and south central USA. Ehrlichiosis is replicated in the lab by PCR, polymer chain reaction, and that is replicating the bacteria E. chaffeenis, which is how we're identifying HME. So how we do that is we take these ticks from the field condition into the laboratory condition and crush them and extract that to examine um, how much to examine if they do have HME, if they are carrying it. Now, the emergence of this disease is closely associated with the large vertebrate counterpart to the Lone Star tick, which is the white-tailed deer, which we believe the Lone Star tick takes it. No, well, we know that the Lone Star tick takes the pathogen from the large vertebrate species and transmits it to humans. Now, even the larvae are being connected to transmission of HME because of transmission of this through oviposition. Now, the range of the Lone Star tick is host dependent on its large vertebrate species. In this case, for the Lone Star tick, it is the white-tailed deer. Now, the spatial distribution of the Lone Star tick is dependent on the white-tailed deer as well. We've seen this through deer exclusion, where the abundance of the ticks are cut down to just spatially being distributed to the range of the host vertebrate species in that area. Now, the absence of the white deer in these areas has been seen to increase the abundance of ticks, but also it increases the abundance of disease in that area, keeping it further away from humans, because the ticks will be carrying the disease, but they will no longer be getting it from the white-tailed deer. They'll be keeping it in that specified area, not transmitting it to their new hosts. Now, we take a look for larger vertebrates, hosts as adults and nymphs. Now, what happens is there are 3 host species. So the larva will attach to their large vertebrate host, obtain a blood meal, fall off, molt, and then go into the next life stage. Now, when they're nymphs, this is where we see a good percentage of transmission to humans, but there's so many nymphs that they could be the the main cause of transmission, even more than adults. Although that there is a higher percentage of adults that transmit than nymphs, there's a higher number of nymphs. Now, they'll do the same thing. They'll attach their host, they'll molt, and then after they get their blood host, they'll drop off molt, and then they'll go to the next life stage, and this is when we observe them transmitting HME to humans. Now, we have seen adult long-star ticks passing the pathogen on to their eggs throughout, and then they're just hatching with it as well. So the larvae are now being linked to transmission of HME. There are activities such as deer exclusion, controlled burning of fields, and climate change that have been observed to control the spread of disease. Now, controlled burns at 1-year intervals are observed to control tick population. 1 and 2-year intervals, while 4 and 20-year post-burn seem to increase the abundance of ticks, because they'll only be away from that area for so long until the deer, because when you burn this area, it works as an active deer exclusion, but deer will come back to this area 4 years post-burn, and they'll start to forage, which they'll bring the ticks back, and then the ticks are going to reproduce and overtake that area again. Now, the exclusion of white-tailed deer has been observed to reduce the spatial distributions discussed in the last slide. But like we said, it does cause hotspots, so it would be a good way to control where the ticks are actually being distributed and away from humans. The abundance of the ticks in upland oak hickory habitats is due to the white-tailed deer's foraging in that habitat. So there's no significant difference with a p-value of less than 0.1 in the deer's utilization of habitats. Climate change does affect the tick seasonality and infectivity, as ticks quest only when temperature is above 44 Celsius and humidity is above 80%. So we're observing that climate change is affecting the transmission of ehrlichiosis, and not just the ticks activity. So I do appreciate y'all's time, and y'all have a good one.